Good morning, students. Today's topic is synthetic rubber and fiber. Let us recollect what we have discussed in the last class. So, what we have discussed in the last class, what is natural rubber, characteristics and structure of natural rubber, vulcanization, characteristics of vulcanized rubber. So, once again, we will revise these topics. So, what is natural rubber? So, from where rubber is extracted? The rubber is extracted from trees. Okay. So when you make cuttings in the stem of the tree, you get a milky liquid that is called latex. That latex contains rubber particles. So latex contains nearly 35% of rubber and it is diluted to 20%. To this 20%, acetic acid, formic acid is added to coagulate rubber particles. These chemicals are called as coagulant because coagulation is taking place. That's why it is called, these are called as coagulants. These are added to maintain the pH around 5 to 5.7 where coagulation takes place. That means around this pH only coagulation takes place. Rubber obtained is called raw rubber or crude rubber. So whatever you are getting rubber by this process, that rubber is called as crude rubber or raw rubber. So this is the structure of the natural rubber. So in the latex, we have rubber particles. Rubber particles are nothing but isoprene molecules. So when you add chemicals, they will undergo coagulation. That means these all isoprene molecules come together. That means they undergo polymerization. So 2-methyl-butadiene is the isoprene molecule. So these are the molecules present in the latex. When chemicals are added, these undergo polymerization. So this is which polymerization? Addition polymerization. So here two double bond will be shifted to middle, CH2, CH3, double bond, CH2. So this is the structure of the natural rubber. So isoprene molecule. So undergoing polymerization. So which polymerization? Addition polymerization. So you are getting polyisoprene. So this is nothing but natural rubber. Then come to the characteristics of natural rubber. It is having low tensile strength. The elasticity of the rubber is the range of temperature 10 to 60 degrees centigrade. It is having high water absorption capacity. It becomes soft at high temperature and brittle at low temperature. It undergoes deformation when stretching force is applied. Less resistant to chemicals like benzene, HCl, undergoes oxidation in presence of air. So these are the characteristics of natural rubber. So then come to the vulcanization of rubber. So what is vulcanization? The process of heating of raw rubber with sulfur at 373 to 415 Kelvin to increase the strength of the rubber is called vulcanization. So why we are doing vulcanization? To increase the strength of the rubber, we are adding chemicals. So the chemical is sulfur here. So addition of sulfur to the rubber is called as vulcanization. And this vulcanization is carried out to modify some properties like sensitivity to heat, low tensile strength, high absorption of water. So these all characters are modified if you do vulcanization. The rate of vulcanization depends upon three factors. That is, first one is amount of sulfur added, second one is temperature, third one is duration of vulcanization. The amount of sulfur added in the vulcanization is this one, 0.15 to 32% is the minimum, this is the maximum. The strength of the rubber depends on amount of sulfur added. So strength depends upon what? Amount of sulfur added. For example, tire rubber contains 5% sulfur and hardest rubber or vulcanite contains 32% sulfur. That means it contains maximum sulfur. The strength of rubber increases during vulcanization. How it increases means due to formation of the sulfur bonds at double bonded carbon atoms between adjacent polymer chains present in the natural rubber. So whatever the polymer chains present in the natural rubber, In between the double bonded carbon atoms, their sulfur bonds are forming. So we'll see the equations. So this is the structure of the natural rubber. So here to here one isoprene, here to here one isoprene. Like this, isoprene molecules goes on continuous like this. It is polyisoprene. This is one polymeric chain, this is one polymeric chain. In between these two polymeric chains, sulfur, when you add sulfur and when you heat it, this sulfur will go and attack at the double bonded carbon atoms. So here, this is sulfur, only one sulfur here. So like that, you are getting a rubber called as vulcanized rubber. After adding sulfur, you are getting a rubber. That rubber is nothing but vulcanized rubber. This whole process is called as vulcanization process. The next come to vulcanized rubber. So to improve the properties of natural rubber, we are adding sulfur or we are doing vulcanization. So we'll see the properties of vulcanized rubber. So its properties will be changed. Low water absorption capacity, high tensile strength, resistant to heat and chemicals, wearing ability, increased strength and durability, increased thermal and electrical resistance, good resilience, that is deformation. Load is removed, it again comes to its original shape and resistant to chemicals. So these are the properties of vulcanized rubber. So after natural rubber, we have topic synthetic rubber or elastomer definition. So what is synthetic rubber? It is a man-made vulcanizable rubber like polymer which can be stretched to at least twice its length. But when the stretching force is removed, returns to original shape are called elastomers. Example, vinyls and neoprene. So these are the topics we discussed in the last class. Today we are going to discuss this. So after completion of this period, you will be able to understand this. What is synthetic rubber and what is fiber, preparation and uses of synthetic rubber, preparation and uses of fiber. Okay, so synthetic rubber is studying. So what is synthetic rubber? It is a man-made vulcanizable rubber like polymer, which can be stretched to at least twice its length. But when the stretching force is removed, again comes to its original shape. That means it again regains its shape. That is called as synthetic rubber. So already we studied synthetic rubber definition in the last class itself. So now we'll study important synthetic rubbers. So few rubbers are given, its preparation and uses are given. So first one is butyl rubber, or it is also called as isoprene rubber. Butyl rubber or isoprene rubber. So how it is prepared? It is prepared by copolymerization of isobutylene. It is 98% isobutylene and remaining isoprene is 2%. So in your syllabus, you have addition polymerization and condensation polymerization, but you don't have copolymerization. So already we studied copolymerization is prepared by adding two different monomers. So to see here, this is one monomer, this is one monomer. This is isoprene molecule, this is isobutylene molecule. So iso, for one carbon, if two methyl groups are there, that is called as isobutylene. Actually, here double bond is there, it is not shown here. So it is pasted on. So I will write here. This is isobutylene. So already studied isoprene molecule. This is the isoprene. CH2, C, CH3, double bond, CH, CH2. So this undergoing which polymerization? Copolymerization. So this CH, actually CH2 here, CH3, CH3, and this CH2, again CH3, CH2, okay, goes on adding like this. So this is the isoprene molecule and isobutylene. They are undergoing copolymerization and you are getting dirubber are isoprene rubber. Okay, if you see here, this is the isoprene molecule. This is the actual structure. Two double bonds, isoprene. CH2 double bond, CH3, CH2. Then isobutylene. Yes, this is wrong pasted. Double bond will be there here. So I will write here. Isobutylene will be like this. CH3. This is the isobutylene. 1, 2, 3, 4. So this is the isobutylene plus isoprene. CH2 double bond CH3 single bond CH double bond CH2. So these two are undergoing which polymerization? Co-polymerization. And we are getting a, this is isobutylene, this one is isobutylene, and this one is isoprene. So isobutylene and isoprene undergoing co-polymerization. So here double bond will attach here. This double bond will shift to here, and this double bond will again combine with one isobutylene like this. So that we are getting butyl rubber. CH2 converts to single bond H3 CH3. Then bond takes place here. CH2 single bond CH3 double bond CH single bond CH2. This bond. So this is one monomer and this is one monomer. Okay. That means number of isobutylenes are combining with n number of isoprene molecules. So here different monomers, n number of isobutylene and n number of isoprene. So this double bond will come and attack here, and this double bond will shift to here, and this double bond will combine with another isoprene like this. So this is the butyl rubber. Okay. So here actually this one is not correctly shown. Okay. So here double bond is not shown here. So here isoprene, direct polyisoprene given. Okay, isoprene molecule. So like this. So if you see here, this one. This is the isobutylene. This is isoprene undergoing copolymerization. Here M number, N number. That means this means 3 parts. This is 2 parts like that. M number of isobutylene and N number of isoprene molecules are undergoing copolymerization, and we are getting a polymer called as butyl rubber. Okay. Then we will see the uses of butyl rubber or isoprene rubber. So this rubber is prepared by butyl rubber is prepared by which polymerization? Copolymerization. In copolymerization, what is happening? So this one is somewhat mistake. So this is 98% butylene, isobutylene, and 2% isoprene is undergoing. And we are getting a rubber called as butyl rubber or isoprene rubber. So we'll see the uses. It is used in adhesives, that is for attachments, lubricants for lubrication, and sealant, sealing purpose. It is used as tire tubes. Tire tubes also used. It is also used in fiber optic compounds, agricultural chemicals, and electrical fuels. So in agricultural chemicals also it is used, and electrical fuels also it is used. So this is about butyl rubber. Then come to the second rubber, S. It is prepared by copolymerization of 3 parts of butadiene and 1 part of styrene in presence of catalyst. So how it is prepared? 3 parts of butadiene and 1 part. So 2 different monomers, okay, different percentage in the presence of catalyst. So butadiene, but means 4 carbons, di means 2, ene means 2 double bonds at first carbon, at third carbon. Okay, this is the butadiene. Is reacting styrene. Already we got polystyrene. Styrene for ethylene group, on hydrogen we are removing, we are keeping benzene ring in C6H5. That means we are removing 1 hydrogen. So this is the styrene molecule. So what is happening? It is also undergoing copolymerization. So double bond is shifting middle, and this bond will go and attack here. So this double bond will break. Very simple. Okay. Butadiene and styrene undergoing copolymerization, and you are getting the styrene butadiene rubber, or simply it is a S rubber. So first rubber also prepared by copolymerization, and second rubber is also prepared by copolymerization. Butadiene and styrene are undergoing copolymerization, and we are getting a rubber called as S styrene butadiene rubber. So then we'll see the uses. Used for floor tiles, footwear components, etc. Used in the automobile tires, used in the cable insulation, carpet backings, adhesives. It is also used as an adhesive, that is means for sticking purpose. So carpet backside fillings, okay, backside making. So these are the uses. And third rubber is neoprene rubber or GRM rubber. It is also called as GRM rubber, neoprene rubber or GRM rubber. So it is prepared by addition polymerization of chloroprene. Chloroprene is nothing but 2-chloro-1,3-butadiene. Hence, neoprene is a polychloroprene. So, how neoprene rubber is prepared? It is prepared by addition polymerization. So, first 2 rubbers are prepared by copolymerization, whereas this one is prepared by addition polymerization. So, what is the monomer here? Chloroprene. Chloroprene is nothing but this is a chemical name 2-chloro-1,3-butadiene. Already in the last class, butadiene means CH2 double bond CH double bond CH. So here one hydrogen removing, we are keeping chlorine. That means in second position we are keeping chlorine. So 2-chloro, First carbon, second carbon, third carbon, fourth carbon. And second carbon, chlorine group is there. So 2 chloro, 1, 3. And first carbon, double bond is there. And third carbon, double bond is there. So that's why 1, 3 butadiene. This is called as chloroprene, common name. This below one is the chemical name. This above one is the common name. Chloroprene is a common name and 2-chloro-1,3-butadiene is a IUPAC name. So this chloroprene is undergoing which polymerization? Addition polymerization. When just bond, if 2 bonds will be there, bond will be shifted. If 1 double bond will be there, it will be broken. So here 2 double bonds. So double bond will shift to here and here to here. So like that, all chloroprene molecules are go on adding. There is no elimination. So you are getting a polymer called as polychloroprene because many chloroprenes are adding. So that is called as polychloroprene or neoprene rubber, or it is also called as GRM rubber. So neoprene rubber is prepared by addition polymerization of chloroprene molecule. Then come to the uses. It is used for wire insulation and cable wiring and linings of reaction vessels. So for wire insulation we are using, for cable wiring we are using, and for linings of reaction vessels. So we will use in laboratory reaction vessels. For those linings we will use. It is used for making hoses, gaskets, and tubing for carrying corrosive gases, oils, and petrol. So hoses mean very, very long pipes that are called hoses. Then gaskets means pressure cooker watches, and tubing means piping for carrying. So from one place to another place, the corrosive gases or oils or petrol. And it is used for making power transmission belts. So power transmission belts will be there now. So for that, and conveyor belts. So you see the airports for goods carrying conveyor belts, and adhesives for sticking purpose. It is also used for preparing gloves. Hand gloves will be there now, aprons and household articles. So by this neoprene rubber, household articles also prepared. Okay, gloves, hand gloves while playing cricket, whatever, while doing operations, gloves will be wear, no? So that gloves also prepared by this neoprene rubber. So these are the uses of rubber. So this is our preparation and uses of synthetic rubber. So next our topic is fiber. So what is fiber? It is very, very small topic. Long, thin and thread-like polymers having high tensile strength and modulus are called fibers. So that is a very, very long and thin, very, very thin, and it will be same thread-like. Its tensile strength will be more and modulus will be more. Those are called as fibers. These are strong as threads are strongly attracted by intramolecular hydrogen bonds. So these are very strong and these are attracted by. So you have two bonds, that is intramolecular and intermolecular. Within the molecule, hydrogen bonds will be there. Those are called intramolecular hydrogen bonds. These may be natural or man-made, and these fibers also, natural fibers will be there and artificial fibers will be there. So example for fibers: cellulose, wool, pterylene. So these all are fibers: wool, cellulose, and pterylene. So in your syllabus, 2 fibers, I think, just 2 fibers. Okay, so we'll see the preparation and uses of those fibers. So first one is nylon 6,6. Already we studied this example in the condensation polymerization. Okay, so in condensation polymerization, we have given this nylon 6,6 only because this is prepared by condensation polymerization. So it is a condensation polymer prepared by reaction between adipic acid and hexamethylene diamine. So condensation polymerization taking place between 2 monomers. That is, first one is adipic acid and second one is hexamethylene diamine. Both monomer units consist of 6 carbon atoms. In both the monomers, 6 carbon atoms are present and named as nylon 6,6. So in these 2, carbon atoms are 6. That's why it is named as nylon 6,6, and it is a polyamide. So it is a polyamide. So we'll see the structure here. So this is the adipic acid, COOH, COOH, CH24. With CH2 groups are 4, CH2, 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 like that. COOH. So this total 6 methylene groups are there, 6 carbon atoms. Okay, 6 carbon atoms are there. Then we have 4, 5, 6. Then hexamethylene. Hexa means 6. The 6 carbons. Methylene groups are 6. That's why hexamethylene. Here 4, 5, 6 carbon atoms. Here total 6 carbon atoms. And amine groups. Diamine. This side one amine. This NH2 group is called amine group or amine group. Diamine or diamine. Hexamethylene diamine. Okay, n number of adipic acid and n number of hexamethylene diamine undergoing which polymerization? Condensation polymerization. That means here what will happen? Water molecule will be eliminated. So here OH, H. This side OH and one more hexamethylene. This H and OH, like that. So OH will be removed, CO, CH2, 4 taken by CO. This here H will be removed. NH, CH2, 6, NH here H will be removed. So like that goes on. Adipic acid and hexamethylene diamine groups are added together. So like this we are getting a fiber called as nylon 6. It is a polymer. It is not plastic. It is not rubber. So it is a fiber. Nylon 6 is a fiber. Okay. So it is prepared by condensation polymerization. So uses used in fibers for textiles and carpets. As it is a fiber for textiles and carpets, it is used making bristles. Brush hair will be there, no? That is bristles. Used in jackets, sport bags, tents, bathing suits, parachute canopies. So you know all of you parachute canopies. In that parachute canopies also, this nylon 6 is used. And come to the next. Polystars. So polystars are condensation polymers prepared by reaction between diols and dicarboxylic acids. So these polystars are also a condensation polymers. Condensation polymers means these are prepared by condensation polymerization. So reaction takes between diols means 2 alcoholic groups, OH groups, and dicarboxylic acids means 2 COOH groups. In between these two reaction takes place. So example for polystars, polyethylene terephthalate, shortcut PET, or it is also called as steriline or dacron. 3 names: polyethylene terephthalate, PET, shortcut steriline or dacron. So it is prepared by reaction between ethylene glycol, simply we will call it as diol, and terephthalic acid, phthalic, PTH actually. Terephthalic, PTH. Here T will be there. PTH. PTH is there, no? PTH, phthalic, P silent acid. This dicarboxylic acid at 420 to 460 Kelvin in the presence of zinc acetate antimony trioxide catalyst. This is the temperature maintained, and this is the catalyst name. Zinc acetate antimony trioxide is the catalyst. In the presence of this catalyst at this temperature range, these are reacted: ethylene glycol and terephthalic acid. So I will show here ethylene glycol structure and terephthalic acid. So ethylene glycol is nothing but 2 OH groups. This is ethylene, CH2, CH2. This side OH group, this side OH group. So that is ethylene glycol and terephthalic acid. So benzene ring. Okay. This benzene ring, COOH, COOH. This is dicarboxylic acid. The COOH group is called as dicarboxylic acid. So that's why it is called as dicarboxylic acid, terephthalic acid, this name is. This is undergoing reaction with this one. So from this OH group remove, from this OH group remove. Okay. So here H is removed, H is removed. So CO, benzene ring, CO, O. Here O will remain CH2, CH2O. Okay. So like this. Like this we are preparing terylene. Okay. Then uses. It is used as cushioning and insulating material in pillows and comforters. Pillows, all of you know pillows. In that cushioning material will be used, insulating material, and comforters like sofas. Their cushioning material used as an means wool, rope in car tire reinforcements. Reinforcements mean to strengthen, to make it strong. Used in blending with cotton and wool fibers and also in glass reinforcing material in safety helmets, conveyor belts. So for strengthening, so in safety helmets and conveyor belts also it is used, and it is mixed with the cotton and wool fibers. So these are the uses of this terylene. This is the terylene. This name is terylene or polyethylene terephthalate or dacron. This is a fiber name. How this fiber is prepared by ethylene glycol and terephthalic acid. So this fiber name is terylene or dacron or polyethylene terephthalate. Okay. So what we have discussed in this class. So in this period we discussed what is synthetic fiber, synthetic rubber, and what is fiber, preparation and uses of synthetic rubber, and preparation and uses of fiber. Okay. Then come to the questions. So what type of questions you get? What is synthetic rubber and what is fiber for 1 mark question. Then preparation and uses of synthetic rubber, preparation and uses of fiber. So in your syllabus we have 3 synthetic fibers. 3 synthetic rubbers and 2 fibers. So among 2 rubbers, first 2, it is butyl rubber and vinyls are prepared by copolymerization, and neoprene is prepared by addition polymerization. See here, this butyl rubber is prepared by copolymerization, and this vinyl is also prepared by copolymerization. And next, neoprene is prepared by addition polymerization. This is very, very simple. And then in fibers, 2 fibers are there. So what is the name of the first fiber? Nylon 66. And second one is the dacron polyethylene terephthalate or terylene. These 2 fibers are prepared by condensation polymerization. Okay. So they will ask, write the preparation and uses of rubber which is prepared by addition polymerization. This is indirect way asking question. So which rubber is prepared by addition? Neoprene. So that we have to write the preparation of neoprene. That all they will ask, write the preparation and uses of rubbers which are prepared by copolymerization means you have to write the butyl rubber and vinyl. 2 means you have to write both 2. If anyone means you can choose anyone. Vinyls are either butyl rubber. So vinyls and butyl rubber somewhat difficult. You have to practice those who are copolymerization. Copolymerization means 2 different monomers. That means if it is 5 parts, one monomer is 5 parts, another monomer is 3 parts. The percentage will be different. And monomers also different. One is acetylene, one is isoprene. Okay, so like that rubbers are prepared. And fiber also somewhat difficult. So first one is already in condensation polymerization we studied. This is adipic acid. Adipic acid means dicarboxylic acid, COOH, COOH, CH2 taken 4 times. And hexamethylene diamine, that by, if you know the name, by this name you can write this equation. NH2, CH2, 6, NH2. So 6 methylene, CH2 is methylene group, NH2, NH2. Here remove the water molecules, you'll get the Nylon 6,6. And here phthalic acid means benzene ring, two sides COOH, COOH. And ethylene glycol means CH2, CH2, OH, OH. So your water molecule is eliminating, you are getting a fiber called as dacron or terylene or polyethylene terephthalate. Okay. So with this we finished synthetic rubbers preparation and what is fiber and preparation of fibers, food fibers, uses of fibers and uses of rubber. And these users may ask for 3 marks or 1 mark, or combinedly they will ask preparation and users. Okay. So you have to practice these equations, then only you get. With this we finished this third unit, that is polymers. So what we have studied first, what is polymer, what is monomer, what is polymerization and types of polymerization. The next topic is plastic. What is plastic? What are the characteristics of plastics? What are the advantages of plastics? What are the disadvantages of plastics? Then plastic types, thermoplastics, thermosetting plastics definitions. Then you have differences between thermoplastics and thermosetting plastics. And next we studied the preparation and uses of plastics. Total 6 plastics are there. Is polythene, PVC, Teflon, polystyrene, bakelite, urea, formaldehyde. These are 6 plastics. Its preparation and uses. Then rubber. What is rubber? How it is extracted? How chemicals are added? What is vulcanization? What is the vulcanization process? What are the properties of natural rubber? What are the properties of vulcanized rubber? Then synthetic rubber. Today we studied preparation and uses of synthetic rubber and fiber. Okay, with this we finished third unit. In next class we will deal with the fourth unit, that is here's very simple unit. Okay, thank you students.